really understand fully exactly what you do and what work you show for your binomial PDF versus CDF. So here we go. Number one actually is review of what we have already done, because it's a problem where, and during this page we'll be talking about the probability of a left-handed man is 13%, okay? And here we're going to say if you get a randomly selected sample of 50 men, what's the probability that you get exactly 10 of them? All right, so a couple things here. Number one, we have a set number of items, so that's going to be lend us to be binomial, and then they're either left-handed or they're not left-handed. Okay, the percent's going to stay, the probability is going to stay the same throughout. Additionally, we're going to have exactly 10 successes. Okay, and then the formula chart has this formula for these binomial problems. So let's remember that the probability of getting, something that you're looking for, a specific value, is, actually I think it is a K there. Probability that what you get is exactly how many successes you were looking for is the number of combinations. Remember that was N choose K. And this is nothing new. This is on the formula chart. I'm just kind of reminding you. And then we have the successes portion. So the probability of success, and there are K of those successes. And then the probability of failure would be 1 minus P, and the rest of them, the rest of the N minus K, are failures. Okay, so there's a formula because we need that in order to show work. So let's do that here on number one. What we're going to do is go through the probability that x equals 10, since that's exactly what you're looking for. So that means we want 10 of them sprinkled throughout. Now you have to show work, and then you can go get the answer from your calculator. So the work you need to show is putting it into the formula. 50, choose 10, no fraction line there. The probability of success is 0.13, and I want 10 of those left-handers. And I want, which would make how many of the not left-handers? Okay, that would be 40, but with the probability of 0.87, and 40, since that's the rest of the 50, because 40 plus 10 is how you get that 50. All right. Now I'm going to go ahead and write down the calculator speak, just so you can see what I type into my calculator. I'm going to be typing in binomial PDF, because I just want, in particular, exactly 10 of them to be sprinkled throughout. 50 with a rate of 0.13, 10 of them. Okay, so we'll go do that real quickly. So second bars, binomial PDF, 50, comma, 0.13, comma, 10. I want 10 of those sprinkled throughout. So that is your 0.0539, and let's translate that. That means, that we've got 5.39%. What? What is that telling us?
That's models. For some reason, I have enough math models for everybody.
Oh, okay.
In pre-K.
Okay, gotcha. Thank you.
And can I possibly go up and look at what you've done?
Yes. And I think there's also some more in the office.
Oh, is there?
Yeah.
Let's check with them. Yeah. I will. I'll be back.
Okay, so I'm sorry. 5.39% what? Okay, good. Chance that exactly 10 of the 50 men are left-handed. Okay, very good. All right, so that was nothing new. We've already done that. That was just a review and a refresher. So here is where it gets new for today. And by the way, this is the last of the learning until like January, whenever it is we come back, 5th or 6th, okay? So I'm going to teach you these last two things, and then that is it for now. Okay, so that's exciting. Also, I would like to tell you that I really think this is the harder of the 2 semesters. Next semester it gets pretty repetitive. You know, there are new things, but it gets a lot of repetitive stuff instead of so much new, so much. So let's move on. Here we go. Number 2, use the information above about left-handed men, so 13%, and find the probability that there is at most 15 left-handed men in the sample of 50. Okay, so if there is at most 15 in the sample, what can there be? Good. There actually can be cumulative 0 of them up to 15. Okay, so you could do exactly 0 of them plus exactly 1 of them plus, and so on, up to exactly 15 of them, and that would be a whole lot of PDFs that you would have to add together. The probability of 1 sprinkled throughout plus the probability of 2 sprinkled throughout plus the probability of so on and so forth, 15 sprinkled throughout. Okay, so because we don't want to have to add up all of those binomial PDFs, we can do the binomial CDF. Now, here's how that would work. We can use the cumulative feature on our calculator, but we want the successes to be less than or equal to 15. And you still have to use the formula, but luckily, you do not have to write out all of those 16 numbers, 0 to 15. You can just write the first in the series, and then put plus, dot, 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 plus, and then use the last in the series. Okay, so here's how that would look. The first in the series would be how many left-handers? 0 left-handers. So 0.13 is 0, and 0.87 is what? If 0 or 0.13, then how many are 0.87? Okay, 50, very good. Plus, dot, 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 plus, and now you put the last one in the sequence. Okay, so the last one of the sequence is going to be 50. Choose how many? 15. Very good. So 50, choose 15. And we've got the 0.13 to the 15th power, the 0.87 to the, how many are going to be 0.87 if 15 are 0.13? 35. Good. Okay, equals. So now let me show you what you put in your calculator. So here is, and you don't have to write this down, but I am going to just to show you. What goes in your calculator is binomial CDF of a total of 50, comma, 0.13. This is the up to and including 15. So whatever number goes here, so whatever number goes right there is up to and including. Okay, so you are including that number right there. So let's do that. Second bars go up until you get to binomial CDF, which is right under binomial PDF. 50, comma, 0.13, comma, up to and including 15. Okay, and so there it is. So it's highly likely 0.999, I think 6. So I'm saying 99.96% chance to have at most 15 left-handed men in the sample of 50. Okay, so that's the benefit of cumulative. It combines all of the PDF yes, the exactly 0, exactly 1, plus exactly 2, plus exactly 3, and so on, okay? It accumulates all of those together. So now, let's look at the flip side to this. We said at most 15. Let's look at what this is if you have at least 15. All right, so use this information above about left-handedness in men and find the probability that there is at least 15 left-handed men in the sample. Okay, so if I want at least, then I'm finding the probability that X is what? Greater than, good, greater than or equal to 15. So, same thing, I don't have to write them all out. I can put the first one in the series and the last one in the series. So, I want you to try that right now. Try putting the first one and the last one there. Okay, so check how you did on writing it out. Your first term is 52's 15 plus dot 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 plus up to 52's 50. Okay, now I'm going to write a little something here real quick out just because I want to use it as part of a demonstration. So you don't necessarily have to write this out, but I'm going to use it to teach you what's going on with the calculator. So thank you. You're welcome. Sorry. All right. So with this problem here, we are going to accumulate what part of the sequence? Good. This part here is what we want. We want to accumulate 15 up to 50 left-handed men. The problem is that the calculator does not have the capability of accumulating from a midpoint up to the top. The calculator only has the ability to accumulate from the bottom 0 up to a certain spot. So if the calculator only has the ability to compute 0 up to a certain spot, so this is what we could do in the calculator, how can I then get the top part? Very good. Subtract away this part that I do not want from 100%. And then that will give me left this part that I do want. All right, so in the calculator, that would look like this. 1, which is all the possibilities, minus the binomial CDF of 50, comma, 0.13, comma. Now, this is a big deal right here. 14. I am taking off the bottom 14. I am not taking off the bottom 15. If you take off the bottom 15, you have taken off too much. You are only taking off the bottom 14. Okay, so let's compute that. Oh, hold on. I'm going to go 1 minus, and then my second bars, binomial CDF, 50, comma, 0.13, comma, take off the bottom 14, and there it is. So 0.00129. That's not very likely. That's only about a 1.129% chance of getting at least 15 left-handed men out of the sample of 50. When I did my calculator, it started out 1 minus that already, so I had already done the 1 minus portion. Okay, so just be careful with this number right here. Be real careful on exactly what you are taking off. Okay, that's it. Done. So that's accumulating either the bottom part or accumulating the the top part, that's what the work you show, and that's how you do that. So, let's go over to the next page. Let's have you practice a couple of these. Yes. Here we go. All right, so let's say you are insistent upon parking in the teacher's parking lot, and you decide to do that for all the days that you go to school, which is 178 of them. Well, the Aledo ISD parking tickets in the teacher parking lot are given out approximately 2 days a week, which is 2/5 of the time. Therefore, the probability that you get ticketed in that lot is 40% of the time. Okay, what's the probability that you get at most 14 tickets? You think you can handle paying for up to 14 tickets? So I want you to write down how you're going to do that. Show the work and compute it. Do that now and we'll check. What happens here? Yeah. Okay, here's your work you show. It is less than or equal to 14, so it's 178, choose 0.4 to the 0. Okay, plus ... 178, choose 14.4 to the 14. Okay, so that's the sequence that you show. The way you put it in your calculator, which you do not have to show me, is you do not have to write out the calculator speak on the free response or on the test or anything. That doesn't give you anything. I write it just so you can see how I came up with this answer. And you do actually get a very strange one. If you go binomial CDF, because we are going from 0 up to 14, and you get this number here. When you get 2.76, that does not mean 2.76%. That, if you get something like that, you need to automatically look at the end of the line, because it probably has something like this, 10 to the negative 22nd. So if you've got 2.76 times 10 to the negative 22nd, look what's happening. 5, 6, 7, 8, 9, 10, 11, 12. You've got all these zeros, 21 zeros in front. So essentially, what's the probability that you get at most 14 tickets? Pretty much 0. 0% chance that you get at most 14 tickets if you park in the parking lot every day. All right, now I want to go ahead and talk to you about 5 and then have you do 5 through 8. Make sure you've got all the work down. So here we go. So what we have here is a study that's being done with 152 patients that have lung cancer. So if the probability of being a smoker among a group of cases with lung cancer is 60%, what's the probability that a study with 152 patients has exactly 75 patients that are smokers? And then number 6 is at most a certain amount, and then 7 and 8 are at least. So I want you to do those 4 problems there, and then we'll check those back here in a second. Okay, let's check and see how you did. Let's pay close attention to the work that was shown. Make sure that you were able to do that. Okay, so this wasn't exactly. And so this was a PDF because it wasn't exactly 75. So that's the work that you showed. And there's the answer you got. Yes, so on the calculator, it looks like this. Second bar's binomial PDF, and out of 152, is that what this was? With a 60% success rate of being a smoker, and then they wanted exactly 75 of those. And so then that's how that came out, 0.00191. Okay. Now here, we started having some accumulation, because if we want at most 50, then we want less than or equal to 50. So then we accumulate from the bottom. So that means that when we show our work, we have to show the sequence. The first in the sequence, which was 152, choose 0, plus ... up to the 50th one in the sequence. And then the way that looks in the calculator, you know what, I'll text you the homework. Okay. The way that looks in the calculator is this binomial CDF of 152, comma 0.6, comma 50. That does come out to be 136 times 10 to the negative 11th. So that's about 0% chance that you would have at most 50 smokers. Probably going to have more than that. Okay, 50% chance that you're going to have 50 smokers or less. All right, the next one was at least 85 patients are smokers. And this one, if you got the answer 82.7, then you made an error, a slight error. Okay, so 82.7% on this is an error. If you did that, then when you computed, you put this number in as 85. That means you would be taking off the bottom 85. But you do not want to take off the bottom 85. You want to take off the bottom 84 because you want 85 and above. Okay, so you take off the bottom 84 because you want 85 and above. 8 is the same way. I did not write the work on this. But here is taking off the bottom 99 so that you get 100 and above. Okay? And that gives you an answer of 0.0839. So 8.39% chance that there would be at least 100 patients. So it's probably going to be somewhere in the middle there. All right, that's it. Now, as far as your assignment goes, what you need to do in class right now, I'm going to see if you can take the last 10 minutes to finish these problems here on the 12 days of statistics, 5, 10, and 11, and also do this warm-up. I actually am going to be sending you a video of this warm-up because a lot of people have been asking me about number 6. So later today I'm going to send you stuff today and send you stuff the exact same thing on Sunday afternoon. I'm sending it to you today just in case somebody feels like doing their homework tomorrow, which I don't really anticipate that would be very many people, but I just wanted that to be out there in case you wanted to. All right, but Sunday afternoon about 2 o'clock, I'm going to send you this information again, and it will be a video of this warm-up, and then I'm also going to give you a hint video on your homework. Your homework is a start of the review for the entire unit, chapters 14 through 17. So in summary, by the time you come back on Monday, you have to have pages 53 through 56 of your packet done. And I know that's a lot of homework, and I'm sorry I don't do that to you very often, but it has to happen that way this time. Again, I'll send you a hint video, so in case you're getting stuck. All right? So there's that.